Okay, a very good morning to all of you. Um, I'm sharing the QR code. Okay, give your attendance and then we will start. Give the attendance and we will start. Okay, so I think I'm done with your attendance. So we can start. Okay, so in my yesterday's class, I have discussed with you about the Wheatstone bridge, right? And I also told you about the limiting error of Wheatstone bridge. Okay, these are the limiting errors formula of Wheatstone bridge. And I told you that Wheatstone bridge has some limitations, insufficient sensitivity of the null detector, then thermal EMF, okay, leads and wears, error due to lead connection, then changes in resistance of the bridge. Okay, so all there are many limitations in Wheatstone bridge. So definitely, if there are some limitations in a device, then what we need to do, we need to go for any kind of advanced device. Okay, that we will see later on. What are the advanced devices after Wheatstone bridge? But before that, you see this formula clearly. Okay, this formula that written here, the using first order approximation, the formula you can see here, Rx is having this formula. You just take down this in your copy because now we will do two problems. Okay, take down this formula. Rx equal to R3 R2 by R1, 1 plus del R1 by del R1 by R1. This formula you just take down in your copy. I'm dictating a problem, okay, and you will solve it. Just take down the problem. I'm audible now clearly? Am I audible clearly?
Yes,
Hello.
ma'am.
Okay. Take down the problem, okay? Write down. In a Wheatstone bridge circuit, in a Wheatstone bridge circuit, in a Wheatstone bridge circuit, R3, that means this one, R3, the first term of the equation, R3, in a Wheatstone bridge circuit, R3 is a R3 is a decayed resistance. In the problem it's given decay, D-E-C-A-D-E, decayed resistance with a specified accuracy, in a Wheatstone bridge circuit. R3 is a decayed resistance with a specified accuracy, of plus minus 0.2%, okay, accuracy of 0.2%, and accuracy is plus minus 0.2%, okay, and R1 and R2, is 500 ohm, plus minus 0.1%, plus minus 0.1%. So R1 and R2 is 500 ohm plus minus 0.1%. Full stop. Then you write, if the value of R3 if the value of R3 at the, if the value of R3 at the, if the value of R3 at the null position NULL, if the value of R3 at the null position is, if the value of R3 at the null position is 520.4 ohm, determine the possible minimum, determine the possible minimum and maximum value of, determine the possible minimum and maximum value of Rx. Determine the maximum, determine the possible minimum and maximum value of Rx. R in suffix you need X. So Rx you have to find out, okay? In the problem you are given R3, R1, R2. I'm repeating the problem once again, okay? Just check it out. In a Wheatstone bridge circuit, R3 is a decayed resistance with a specified accuracy plus minus 0.2%. Okay, and R1 and R2 is equal to 500 ohm plus minus 0.1%. First off, if the value of R3 at the null position is 520.4 ohm, if the value of R3 at the null position is 520.4 ohm, determine the possible minimum and maximum value of Rx. So what you have to do? You have to apply this error equation, okay, shown in the PPT, and you have to put the value. See, in the problem, if you follow nicely, you can see all the values are provided, okay. You know what is R3. R3, you know what is R3. R3 is 520.4, okay. You again know what is R1, R2. R1, R2 is 500, okay. And all the del R1, del R2, these are the error percentage. So you can see that error of R1, R2 are similar and error of R3 is 0.2. So put all the values, okay, and then tell me the answer. Put all the values and tell me the answer. You all are doing now the problem. Hello. Hello. Ayushi, Monica. Hello.
Yes.
Yeah.
Yes, ma'am.
कर रहे हो ना problem? Solve it. Solve the problem and tell me. Today Rajkumar is not there. Absent. Pooja is there. Pooja, solve the problem. Tell me the answer. In place of del R1, you have to put 0.1 divided by 100 because it's in percentage. Okay. So every place you have to put that. You have to find the value of Rx. Okay. Tell me the value fast. Till now not done. Taking so much time. Done the problem. Pooja, are you done with the problem? Hello, Please respond. I'm asking something. Ayushi, Avinash, hello?
Rx is equals to
Yes, ma'am.
520.4 plus minus 0.4%.
Yes, correct. Ayushi, correct. Rx is equal to 520.4 plus minus 0.4%. Okay. So nothing to do, just you have to put the values in the specific formula you have. Okay. So I'm not writing the equation once, I'm just writing the you have to just put the Rx, the formulas here. Okay. Rx is this value, 520.4. Nothing you have to do, just put the values, whatever I have told you in this particular problem, then you will easily get the answer. Okay. Okay. Take the next problem, please. Take the next problem, please. Under Whetstone Bridge. Next problem. Write down a Whetstone Bridge has a ratio arm. I think the first problem is done by everyone. Everyone has done the first problem. Monica?
Yes.
Monica, done now? Okay. Take the second problem. A Whetstone Bridge has a ratio arm of, a Whetstone Bridge has a ratio arm, okay, ARM. A Whetstone Bridge has a ratio arm of 1 by 100. A Whetstone Bridge has ratio arm of 1 by 100. So in bracket you write it is R2 by R1. Okay. So a Whetstone Bridge has an arm of ratio arm of 1 by 100 R2 by R1 full stop. At first balance R3 is adjusted to, at first balance, matlab first we are balancing R3. Okay. So at first balance R3 is adjusted to 1000.3 ohm. 1000.3 ohm. So at first, sorry, wait. So at first place, R3 is adjusted, okay? ADJUSTD, adjusted to 1000.3 ohm. Then you write full stop. The value of Rx is then changed. Value of Rx, okay, keep this Rx. Value of Rx is then changed by temperature change. Value of Rx is then changed by the temperature change. And the new value of R3 and the new value of R3 to achieve the balance condition again, and the new value of R3 to achieve the balance condition again is this one, 1002.1 ohm. So this is the new value of R3 and the previous one is the old value of R3. Okay, so you have to find, then you write the question, find the change of Rx due to temperature change. Find the change of Rx due to temperature change. So you have to find the value of Rx. See, you know the value of, you know the formula of Rx. So question is, find the change of Rx due to the temperature change. I'm repeating the question again. A Whetstone Bridge has a ratio arm of 1 by 100, R2 upon R1. Okay. At first balance, R3 is adjusted to 1000.3 ohm and the value of Rx is then changed by temperature change. The new value of R3 to achieve the balance condition again is 1002.1 ohm. Find the change of Rx due to temperature change. Okay, so you have two values of R3. One is the old value of R3, that is this one, 1000.3. This is R3 old, and this is R3 new. Okay, so I'm writing, denoting it with dash. So R3 is that one, R3 dash is 1002. Now the formula of Rx, you know what is the formula of Rx? Yesterday in previous class I told you. If you need to find out one unknown parameter in Whetstone Bridge, what is the formula you need to follow? Formula? Tell me. What is the formula of Rx? Yes.
Rx equals to R3 into R2 by R1.
Yes, R3, R2 by R1. Okay, this is the main formula. R3, R2 by R1. So I hope that you know the formula of Rx. So what you will do, you have to find out two Rx. One is Rx old with the R3 old value, and one is Rx new with the R3 new value. So you tell me the first of all two values of Rx. One is Rx old and Rx new. जल्दी से बताओ. And R2 upon R1, you know it will be 1 upon 100. Okay. So tell me the value of Rx old first, and then tell me the value of Rx new.
Rx old is equals to 10.003 ohm.
Yes, 10.003, correct. Then
And Rx new is equals to 10.021.
10.021, correct. So you have got two Rx, right? One Rx is, I'm writing here, Rx is, first Rx, that is Rx old is 10.003. 10.003 ohm, and this is Rx dash I'm taking, that is the new one, that is 10.021, 10.021 ohm. Okay, so this is my two values. Now see the question, follow the question nicely. Find the change of Rx due to temperature change. That means what you have to do, you have to just find the difference, that is Rx new minus Rx old. Okay, Rx new minus Rx old, because you just need to find out the temperature change of Rx. So tell me the answer. What will be the change in Rx?
0.018.
Yes, very good. 0.018 ohm. So this is my final answer. Okay. So this is the change of Rx due to the temperature change. So I hope these two problems are you have done nicely. Okay. I'm sharing my slide again. So this thing is all about this question. These two questions are depend upon these formulas. So these formulas are important. Okay. One formula is Rx equal to R3, R2 upon R1. That is, you need to find out the unknown parameter. And second formula is about the error. Okay. This error formula is equally important. Now, next, one more thing. Let us move on to the next slide. Let us see what is there. Okay, these questions which you have done. Achha, before going to sensitivity of galvanometer with this Wheatstone bridge, suppose, let me show you, I'm moving on to my whiteboard again. Okay, whiteboard pe ja rahe hain. Suppose I'm giving you a question, and suppose I'm giving a circuit. Okay, follow the circuit nicely. इतना तो अच्छे से draw नहीं कर पाएंगे, जितना होगा I'm doing that. Follow the circuit, okay? You also draw this circuit. Just a Wheatstone bridge circuit. Okay, I'm drawing. And you will fit a null detector in the middle, circle color thing. Okay, and here are all the resistance I'm writing. This is R1, this is R2. Okay, R2, this is R3, this is R3, and this one is R4. R4 or whatever you can R4. So all these four resistances are here. Okay, and let me complete the connection. So I'm completing the connection here. Okay, now you see here the terminals I'm writing. This is A. Okay, this is B. This is C. This is C and this is D. Now, suppose in your question, it is provided R1 is 800. R1 is 800 ohm. Okay. And suppose I'm giving you R3. That is 750 ohm. Okay, 750 ohm. And another value I will give you, that is R2. R2. R2 you take down, it will be 200. Wait. R2 200 ohm. So three values you have. R1, R3, R2. Find out R4, Rx or R4, whatever. Tell me the answer. You need to find out R4. Okay. Tell me the value of R4 first. Calculate the R4 when the bridge is
7.5.
7.5. 7.5. ठीक से देखो. Wait. See, through this problem, one thing which I want to tell you, in my problem, see the resistances position are different. ठीक है? एक चीज notice करो, resistance position are different. And one more thing I want to say that, wait, let me show my this board to you. And this R2 here is this variable resistance. Okay, wherever you will see in the resistance there is such kind of arrow, this means the resistance is variable. Okay, let me share the slide with you first, show you the difference in between the formulas. This picture you have drawn, right? Now I will show you the slide. I'm not able to do it. Okay, now you follow this picture, my question which I have given, and you follow this picture. According to this picture, the formula has come up like this. Okay, R4 equal to R3, R2 upon R1, where R3 is the variable resistance. Okay, see, one thing always keep in your mind, same arm. Okay, always diagonally they will act. Same arm will never work. Okay, never work. That is here in this particular slide, if you can see, R3 is a variable resistance because the arrow is with the R3. Okay, so we have kept R3 separate from the other two resistance, and we have taken the two resistance that are in the same arm but on the same side. Suppose R1, R2 I have taken, so R2 by R1 multiply by R3. Why R3? Because R3 here is a variable resistance. Okay, but now you follow my question, the question which I have given you. See, in the question which I have given you, there R2 is a variable resistance, right? R2 में मैंने arrow डाला है, समझ में आया? R2 is the variable resistance. So I told you to find out the Rx. Okay. So according to that, if you write the formula, how it will come? Here R2 will be separated from other resistances. Okay. So here R2 will be in place of R3. Here R2 will be in place of R3. So how will be the formula will come? The formula will look like this. R2, let me show you. Wait. You have to follow that which one is the variable resistance. I need to find out Rx in my question, but my variable resistance is R2. Okay, so what you have to do, you have to keep separate the R2. And what is my actual formula? Actual formula with respect to this particular diagram is R4 equal to R3, R2 upon R1. Okay, because R3 here acts as a variable resistance. Now, if you take R2 as a variable resistance, then how it will become? Tell me. In my question, R2 is the variable resistance. So how you will write the equation? R2 multiplied by R2 multiplied by क्या लिखोगे? Tell me. You have to find out the Rx, right? You have to find out Rx. So the equation will be somehow like that now. You know R3, you know R3, you know R1, but you don't know Rx or R4, जो भी है. So how you will write the equation? बोलो. बोलो पूजा, कुछ समझ में आया? Anyone, tell me. Don't mix it up. ठीक है? देखो question wise ये the process is same. The process is exactly same, that you have to find out the resistance. It will be just like, but you have to follow definitely according to question that which is a variable resistance. ये भी देखना पड़ेगा. Okay, and which resistance you have to find out. These two things you have to check. अब बताओ. Now tell me the answer. See, according to my question, the formula will be just like this. According to follow my question, the question which I have gave you. Okay.
Mom, answer is 3000.
Yes, the 3000 ohm, right? Pooja?
Yes, ma'am.
3000, yeah. Just kilo ohm you can convert.
Yes, ma'am.
Yeah. It's 3 kilo ohm or 3000 ohm. So this is the right answer, what Pooja did. Okay, just a minute, Pooja. Yeah. Pooja, understood this question?
Yes, ma'am.
Yes. So this is the thing you have to follow, which is the variable. जहाँ पे भी कोई Wheatstone bridge का problem हो, if you see arrow in any of the resistance, you will feel that that arrow is for the variable resistance. Okay. So then the formula will get changed, but whole process is same. Process में कोई difference नहीं है. Okay. So this is the variation. Okay. One problem I will give you for your homework. Then we will move on to the next thing. Wait. Okay, take down another problem. The given values are, this you will do at your home. Okay, practice it and then you will tell me in the next class. You have to prove a thing. Given value R1 given value R1 equals to wait, R1 equals to 2 kilo ohm. Okay, this is a given value. R2 equals to take down 1 kilo ohm. Okay, R3 equals to you take down 1.5 kilo ohm, 1.5 kilo ohm. Okay, and Rx you take down, or R4 whatever, Rx you take down 3 kilo ohm. Okay. 3 kilo ohm. So 4 values I have provided you. Now you have to prove that the bridge is in balanced condition. Okay. So you will do the proof at your home and you will let me know that yes, ma'am, this proof we have done. That means the formula you know, okay, R1 by R2 equal to Rx by R3, that kind of formula you have to use, and you have to prove that the bridge is in balanced condition. So this is particularly for the Wheatstone bridge, and so given values are these things. So you know when the bridge comes in balanced condition, the formula you know, you will just put the values and you will see that whether the LHS and RHS are equal or not. Okay, so this problem we will do at your home. Let us move on to the next topic, or let me show my slide to you. Okay. Okay, coming to this, sensitivity of a galvanometer. Now, galvanometer, you all know what is a galvanometer. It is used to detect an unbalanced condition of Wheatstone bridge. So in any Wheatstone bridge, you will find galvanometer. Okay, in any Wheatstone bridge, you will find galvanometer. So why we use it? We use it because it is used to detect an unbalanced condition in a Wheatstone bridge. See, in Wheatstone bridge, we can have two conditions, balanced, unbalanced. So unbalanced condition is detected by the galvanometer. So its sensitivity is governed by the current sensitivity and the internal resistance. Okay. So first of all, we will consider a bridge circuit, which is have a small unbalanced condition, and we will apply the circuit analysis formula to solve the current through galvanometer. So for that, we need Thevenin equivalent circuit. So have you learned Thevenin before in basic in any subject? Thevenin and those Norton, have you gone through those things in time before? Anyone? Do you know about Thevenin?
Yes, ma'am.
Ha. Okay, so if you know about Thevenin, then I don't have to repeat a Thevenin with you. So if you know Thevenin, you also know Thevenin voltage kya hai. What is the Thevenin voltage and Thevenin current? VTH ka formula kya hota hai? That thing you must know. So we will apply here Thevenin equivalent circuit to find out the to solve the current through the galvanometer. Okay, so if you follow this circuit, which is shown in my particular slide, see, sir, here a Wheatstone bridge have been drawn. Okay, Wheatstone bridge has been drawn, and in the place of the detector, we have used a galvanometer. Have you seen this galvanometer in the middle? So in the place of the detector, we are using the galvanometer. Okay, because galvanometer is used to detect the unbalanced condition of the Wheatstone bridge. Now we have taken all the resistances R1, R2, R3, R4, and we know what are the current flowing through it. Okay, and we have also marked the terminal A, B, C, D. Now you see here, we have to find out the current flowing through galvanometer. That means we have to follow the voltage across the galvanometer. That is the voltage across VCD. Okay, see the terminals across the galvanometer is CD. I'm annotating with the weight with different color. See here across the galvanometer, the terminals are CD. So we have to see that what is the voltage across CD. Okay, then if I say, or if I write this equation, VCD equal to VAC minus VAD. Can I write this equation? VCD is equal to VAC, matlab this arm, minus VAD and this arm. Okay, so you can take any of the two. I'm taking the arm opposite to the galvanometer. So I'm taking this 2 because I need this particular line about VCD. So I will subtract the value of VAC from VAD. That is, in VAC, what is the current and resistance, and in VAD, what is the current and resistance, that I need to know. Okay, and again, I have told you previously, from Wheatstone bridge we can write I1 as V upon R1 plus R3 and I2. So just put the values of I1, I2 in place of this VAC and VAD, or R1 in place of I1, R1. So you will get a Thevenin voltage from this particular circuit. That is the voltage, or you can say the voltage across the galvanometer, across the terminals of the galvanometer. So here terminals are C and D. So this equation is sometimes required if any problems come. Okay, if any problem come, then you have to use this equation. This VTH equal to VCD equal to V and this. And now see, here my terminal naming is like this ABCD. You can change the terminal name as per your requirement. It's not required कि ये ही देना पड़ेगा. ठीक है, but according to your naming, the namings will automatically change. But the main focus will be exactly similar. Okay, so this is all about the Thevenin voltage VTH. Now here some of the Thevenin resistance, and we need to find out the galvanometer current, right? That is IG. So if you have learned about Thevenin resistance, then you must be knowing that the resistance should be parallel, and under parallel they look like R1 upon R3, okay, plus R2 by R4, just like that. Means R1 parallel to R3, R2 parallel to R4. So if you check out the previous diagram in Wheatstone, you can see here R1 and R3 are parallel and R2 and R4 are parallel. Okay, so that thing we have just simplified the circuit, and we have written here RTH, and then if we got the RTH, then we will take it in a single resistance, we will include in the circuit, and we can find out the galvanometer current. Okay, so regarding this portion, I will continue in my next class. Is this complete circuit. Now in in Thevenin, you must be knowing that once we find the RTH, what we do, we concise all the resistance in under one roof. I mean, if I know what is my RTH, then I can write RTH like this. I need a simple circuit where I have a VTH, where I have RTH. And what I need to find out, my current. Okay, so the formula for galvanometer actually comes like this. That is IG equals to VTH upon RTH plus RG. What is RG? RG is the galvanometer resistance. Okay, so this is, you can say, application of Thevenin theorem in galvanometer to find out the current. Okay, so in current finding out, you need all three things: the galvanometer, the VTH, Thevenin voltage, Thevenin resistance, as well as galvanometer resistance. Okay, so we can apply also this formula in particular question problems. So next the topic I will discuss in my next class. Okay, so we have some questions over here to solve it out. So this we will do continue in the next session. Okay, any query up to this, and do follow that question which I gave you, balancing the problem, the 4 formulas I have given you. So वो भी करके रखना है, ठीक है? In the next class I will check it. Okay, once again I'm sharing the QR code with you. If anybody has left out, then give the QR code. And why 11 students are present? Actually, leave me. 10 students are present. Why? What others are doing? New semester, new subject, new session. I don't know what is your problem. Okay, do the sum, and I will upload the notes and give an assignment to you also. Okay, do this sum as your assignment, the sum which I gave you. 4 values are given, and you have to find the whether the is in balance or not. Okay. Okay, so give your QR code if anybody has left out. And thank you for attending my class. And in next class, I will check that problem. Okay. Thank you. Thank you so much.
Okay, thank you.